I am going to explain about rotational motion in biotechnology. Rotational motion happens when an object spins around a fixed axis. A key example is the centrifuge. In biotechnology, a centrifuge uses fast rotational motion to create a centrifugal force. This force will separate biological samples based on their mass. However, the rotational speed must be carefully controlled. If the speed is too high, biological sample can be damaged.
Assalamualaikum and hello. Today I will presenting you about rotational motion in mathematics computer graphics, presented by me, Siti Aisyah binti Al-Iman Al-Syahia. A laptop cooling fan is a practical example of rotational motion in everyday life. When the laptop is operating, electrical energy powers a small motor that produces torque, which is the turning force that causes the fan blades to rotate about a fixed axis. The amount of torque determines how easily the fan starts spinning, while the rotation speed, also known as angular velocity, controls how fast the blades move. Heavy computations and rendering increase the temperature of the CPU and GPU. To manage this heat, the system increases the motor's torque, allowing the fan to rotate at a higher speed. This faster rotation improves airflow and heat dissipation, ensuring smooth performance and preventing overheating during intensive graphical tasks. That's all from me. Thank you.
Do you think high-tech motors are only made of steel? Meet ATP synthase, the smallest biological rotary motor in the world, and it's inside you right now. In physics, we see rotational dynamics here. When protons, these little H plus ions, flow through the membrane, they create torque, spinning the motor's rotor just like this fan. This spinning shaft performs mechanical work. It physically forces ADP and phosphate to bond, creating ATP. It's basically a molecular power plant converting kinetic energy into mechanical flow. By understanding these rotational dynamics, biotechnologists are now designing synthetic nanomotors to deliver drugs directly to cancer cells. Nature's physics isn't just about survival, it's the blueprint for the future of medicine.
I'll be explaining rotational dynamics in mathematics computer graphics. Rotational dynamics plays an important role in computer science application involving motion. In games, it controls how wheels spin or dice roll realistically using torque, speed, and friction. In 3D animation, rotating camera around a model relies on rotational calculations. Without proper angular momentum, the motion will appear jittery or unnatural. In virtual reality, rotational dynamics helps track head rotation. Mathematics ensure the scene rotates correctly when the user tilts their head.
Now I'm going to explain about solid and fluid. In physics, a solid maintains a fixed shape and volume because its molecules are closely packed. In contrast, a fluid, including liquids and gases, has no fixed shape and flow easily when external force or pressure is applied. In biotechnology, solids like cells or microcarrier beads are the factory where production occurs. Fluids act as logistic, flowing through the system to deliver oxygen and nutrient while removing waste. We apply this principle in biotechnology through filtration. We use a solid membrane with specific pore size. By applying pressure to a liquid culture, the fluid is forced through the pores, while larger solid particles like cell debris are trapped behind.
Today, I will explain how solid and fluid in basic physics are related to mathematics computer graphics. Solid physics studies how objects stretch and compress or break. Mathematics is used to calculate stress and strain. For example, engineers use math to make sure buildings and bridges are safe. For fluid physics studies how liquids and gases flow. Mathematics helps calculate pressure, speed, and flow. For example, water flow in pipes and air movement. Computers use physics and math to create simulation. Programming helps model solid forces and fluid movement. This is used in games, animation, and engineering software. In conclusion, solid and fluid physics are strongly connected to mathematics and computer. Math help us understand physics and computer help us apply it in real life.